Hello, you are welcome to New Focused Approach to Mathematics Basic 9. This is the revised edition, and in this lesson, we want to learn how to use diagrams to represent union of set and intersection of set. This lesson can be found in page 10 of your textbook. So, we want to learn how to represent sets, both intersection and union, using diagrams. And so the first example we have here is how do we represent intersection on a Venn diagram? How do you shade the portion to represent an intersection? So let's say we have set A here and set B here. It could be that set A is equal to maybe 2, 4, 6, 8. And set B is equal to 2, 3, 4. Now, first of all, you can see that between set A and set B, there is an intersection, okay? And the intersection of A intersection B is 2 and then 4. 4 becomes both, the number that appear in both sets. So that becomes intersection. So because there is an overlap and there is intersection, in shading, we'll shade this particular portion to represent the intersection. So this is our intersection of A and B. Another example can be like this. Let's say this time around we have set A, okay, this way, and we have set B, which is a subset of set A. So for example, set A is 2, 4, 6, 8, and set B is 2, 8. Okay. Now what it means is that everything in set B can be found in set A. And so our intersection here becomes the same as the element in set B. So in shading this in the Venn diagram, because set B is inside set A, will not show the overlap. Rather, we'll put set B inside set A and we'll shade this to represent the intersection of A and B. And so this is a diagrammatical representation of intersection of A and B if the two sets or one set is inside the other or a subset of the other. Good. So that is A intersection B. Now let's take another example and see if set A is defined as this and set B is defined as this. We want to find A intersection B using the Venn diagram. Now, first of all, we want to know what A intersection B is from the question. And from the question, you can see that 1 can be found in both sets, 3 can be found in both, and then so it's 1 and 3. Okay, that is 1 and 3. And so in the Venn diagram, we'll put 1 and 3 in the intersection position. Now, when we do that with the set of A, after representing 1 and 3, the leftover number in set A will be 2, 4, and then 5. Okay, so that represents set A. So let me call this set A. And let's call this set B. Now for set B, after taking 1 and 3, we are left with 9 and 12. And so this is how we represent set A and B in the Venn diagram with this kind of questions. And so this represents A intersection B, right? Now, how do we represent union also using Venn diagram? We are going to look at this in 3 different categories. The first category is when we have set A and set B overlapping. For example, I have set A given as 2, 4, 6, 8, okay, and set B is given as 6, 8, 9, 10. Now, if you want to find A intersection A union B, then it means you are bringing all the elements together. You are bringing 2, 4, 6, 8, 9, 10 all together. That represents A union B. And so in shading it on the Venn diagram, we'll have it this way. And once again, you see that there are elements in A that are not in B, and there are some elements in B that are not in A. So we have this overlap circle. That is, A and B will be overlapping because there may be some elements that are in A but not in B. So we overlap them this way, and we shade everything together to represent our union. Now, when we take another example, let's say another example. This time around, let's have set A and set B. This time around, they don't have anything in common, so they are disjoint sets. So maybe set A is giving us 1, 3, 5, and set B is giving us 2, 4, 6, 8. You can see that there is no intersection of A and B, and so we can't put the circle together and let one overlap the other. They are two separate entities, but we can still shade their union to be shading this and shading that put together. So in representing this kind of set, the union will be shaded together like this, but we can't overlap the circles. But we can still put them together and say A union B is all about 1, 2, 3, 4, 5, and 8. So that becomes our answer, right? So this representation of A union B where we don't have any element in common. Then the last one with the union of sets can also be like this. Let's say we have set A and set B is inside set A. Okay, so example can be A is equals to 2, 4, 6, 8, and then B is equals to 6 and 8. Every element in B is inside set A, and so we can put set B inside set A. So we say B is a subset of A. Now, when we want to do or shade the A union B, we'll shade everything like this together, and that is how we represent A union B with a set whereby two set, but the one is completely inside the other, right? So that is A union B. Now let's take one more example and then we end this lesson. So for example, here we have if A union B, if A is giving us 2, 5, 7 and B is giving us 1, 2, 5, 8. Find A union B using the Venn diagram. Again, so we know that the Venn diagram, first of all, let's see whether there's an intersection between them. There's intersection between these two elements. We have 2 and then 5 being an intersection. So we position 2 and 5 in the Venn diagram as 2 here and then 5 here as well. Okay, now so and then the element left for A will be 7, element left for B will be 1 and 8. So again, with the Venn diagram, it will still be the same. We still have all our elements put together. So everything here is put together representing our union. So A union B now becomes 1, 2, 5, 7, 8, all put together becomes our A union B. Well, I'm sure with this you've been able to understand how to represent intersection and union using Venn diagram. Thanks so much for watching.